All right, let's dive into something pretty incredible today. We're talking about a massive step forward for AI. We're moving beyond systems that just follow instructions to ones that can actually think for themselves. This is all about something called Agentic RAG, and we're going to break down exactly what that means and why it's such a game changer. So just imagine this for a second. You ask an AI a really complex question. Normally, the AI would just follow one rigid, pre-programmed path. But what if it could actually look at your question, really understand it, and then decide for itself the best way to get you an answer by picking from a whole set of different tools? That's the big idea we're exploring today.
But to really get why this new way is so exciting, we first have to talk about the old way. We need to understand the limits of most AI systems that are out there right now. They're definitely powerful, no doubt about it, but they're kind of on a leash, right? They can only do what they're explicitly told.
Let's try an analogy, because I think this really helps. A standard AI is kind of like a line cook, super good at following one specific recipe perfectly every single time. But if you ask for something that's not on that recipe card, they're totally stuck. The AI we're talking about today, though, it's more like a head chef. It can look at any order, combine different techniques and recipes, delegate tasks to other stations, and basically just figure out a dynamic plan on the fly to get you exactly what you ask for. Or in our case, the perfect answer.
So how do you make that jump from a line cook to a head chef? Well, the secret ingredient is what we call the agent. This is the part of the system that brings real reasoning and planning to the table. It's truly the brains of the whole operation. And this leads us to the official term for all this, Agentic RAG. At its core, it's a system where an agent, our head chef, autonomously decides how to solve a problem. It's not just blindly fetching information. It's building a strategy, figuring out which of its specialized tools it needs to get the job done right.
So what's in this toolkit? Well, a bunch of different things. You have the agent itself, which is the brain making all the decisions. Then, if a question is about some internal company data, it can grab its document retriever tool. If it's a math problem, boom, it pulls out the calculator tool. And for just general facts about the world, it's got a Wikipedia tool. The key here isn't just that it has these tools, it's that it knows which one to pick and when.
Okay, so we've got the agent and its toolkit. But how does it all fit together? It all comes down to a much smarter and more flexible workflow than anything we've seen in a traditional system. Check this out. This diagram shows you the whole process. Your question comes in, and you see the agent sitting right there in the middle, like a switchboard operator. It's deciding, should this go to the document retriever, or maybe the calculator, or is this a Wikipedia kind of question? And once that tool does its job, the information flows through an engine that puts together the final answer.
Let's walk through that step by step because it's pretty cool. 1. You ask your question. 2. The agent doesn't just look for keywords, it analyzes what you're really asking. 3. Based on that analysis, it picks the best tool for that specific job. 4. The engine takes the output from that tool and processes it. And finally, 5. You get a complete, well-thought-out answer.
Okay, so the theory is all well and good, but what does this actually look like when the rubber meets the road? Let's try to peek inside the agent's mind, so to speak, and watch its thought process as it tackles a few different problems.
Okay, first up, we'll ask a pretty simple definition question. What is RAG? A normal system might just do a basic search, but watch what our agent does instead.
The agent's first thought is totally logical. It thinks, okay, RAG is a technical acronym. Wikipedia is probably a good place to start for that. So it makes a plan. Use the Wikipedia tool.
But here is where the magic happens. After it gets the result from Wikipedia, the agent actually looks at it and thinks, you know what, in this context, that doesn't seem right. Instead of just spitting out a wrong answer, it recognizes its own mistake and decides to self-correct. This is that reasoning ability in action. It's incredible. So what's its new plan? It pivots. It decides to use the document retriever tool instead, figuring the answer it needs must be inside the specific specialized documents it has access to. It's adapting its strategy in real time. Now for something totally different. Let's throw it a curveball, a straight-up math problem. This is the kind of thing that would just break a simple text-based AI. And would you look at that? The agent instantly recognizes the numbers and the word multiplied and thinks, this is a math problem. I need the calculator. There's no confusion, no hesitation. Its logic points it directly to the right tool. It grabs the calculator tool, runs the numbers, and comes back with the exact correct answer. See, by having this whole toolkit, it can handle a way bigger range of problems than any single-purpose AI ever could. So now that we've seen it in action, let's zoom back out. Why is this such a big deal? Why does this whole agentic approach matter so much? What are the real advantages here?
Well, first off, you get that autonomous reasoning, which leads to way more accurate context-aware answers. The fact that it supports multiple tools makes it incredibly versatile. It's also context-aware, which means it can remember what you've talked about and handle follow-up questions naturally. And maybe best of all, it's totally scalable. You can just keep adding new tools and more knowledge to make the agent even smarter over time.
And really, that leaves us with a pretty mind-blowing question to think about. We've just seen an AI that can reason, that can build a strategy, and that can even correct its own mistakes. So the real question isn't just what it can do for us right now, but what's the next huge, complex problem we can finally tackle with an AI that doesn't just answer questions but actually plans?